Hi everyone, this is Precious. Alright, so in this video we would like to start by looking at the concept of indices. Alright, so we are beginning with the rules of indices. Okay, so indices is the math that concerns numbers and their powers. So for instance, a to a power of say 2 means a multiplying itself into 2 times, and so on. So the implication is that if I have something like y times y, maybe up to 4 times, so this is the same thing as y to the power of 4. So when you have a number written in index form, the one below is called the base, while the one on top is called the power, or you call it the index, or you call it the exponent. So it is the plural of this word index that we call indices. Alright, so and that's how we got to the concept of indices. And now to do the maths of indices, we need some rules. So I'm going to be discussing these rules in sections. So first of all, we'll talk about these 5 rules. These 5 rules are quite related. Of course, all the rules of indices are related. So but these 5 are much related and easier to handle. So I'm going to take them at once in this video, and then in our next video we'll look at other rules. Okay, so the first rule is called the multiplication rule, which says that if a number, say you have 2 raised to the power of 3 multiplied by 2 raised to the power of, let's say, 5. Okay, so once the basis of 2 index numbers are the same and they are multiplying, the rule says that you should just add their powers. So and then take one base. So this is equal to 2 raised to the power of 3 plus 5, and that's going to give us 2 raised to the power of 8. Okay, so take this as first example. Now secondly, now you should also note that these can go the other direction. So if you are given something like let's say 3 raised to the power of assume you have say x plus 1. Now you can actually write this as 3 raised to the power of x multiplied by 3 raised to the power of 1. Okay, so now why am I showing us this? Because in some occasions it will be necessary to go the opposite direction. Alright, so you need to know that it applies on both directions. So of course this is going to give us, now by this rule that we are going to see here, 3 raised to the power of 1 is 3, and so this will be 3 times 3 raised to the power of x. So it's either you write this way or this way. Both of them will actually mean the same thing. Okay, so that's for the first rule, which is called the addition rule. The multiplication rule. And then for the division rule, if I have this a number of equal bases, let's say 3 raised to the power of 3 all over 3 raised to the power of 1. Okay, so this is the same thing as 3 raised to the power of 3 minus 1. So once the bases are the same, you subtract the powers, and this is going to give us 3 raised to the power 2, which is equal to 9. Alright, so and then for, like I said over here, this can also go the other direction. That means if I can actually write this as 5 raised to the power of 1 all over 5 raised to the power of y. So depending on what I want to solve, so this will give me 5 all over 5 raised to the power of y. So this is just to show us that we can move in opposite directions for what we have here. And then for the third rule says that anything raised to the power of 0 is equal to 1. So if I have something like 6 to the power of 0, whatever is equal to 1. Take note of that. The fourth one says that if we have, okay, so when there is a negative index, so this is the same thing as 1 all over 3 raised to the power 1, and that's going to give us 1 all over 3. Okay, so if I have something like say x raised to the power of minus 2, so this is the same thing as 1 over x squared. So it's important you note that. And then the final one we have here is that anything raised to the power of 1 is the same as that number. Okay, so with all these particular basic rules, we are going to take just one example in this video, and then we will see other examples and other rules in further videos. Okay. Alright, solution. So here we are asked to evaluate this, that's to simplify. And clearly we can see that their bases are not the same and you cannot take them to the same base. So what do? So first of all, you start from where you know and then you progress. So I can write this as 6 raised to the power of 5 over 2 multiplied by, I'll try to remove this fraction. So here I will get 12 raised to the power of minus 2. How did I get that? Because we were told that negative power will change to 1 all over positive power. So that means if you give me this way, I can turn it to this way. And that's how this got this. Okay, so and this is going to be, okay. So first of all, look at the basis of these numbers. You will notice that there is one particular thing common to all of them. And that is that you can break them down to a product of the same numbers. And what is those numbers, or what are those numbers? 2 and 3. So I can write 6 as 2 times 3 raised to the power of 5 over 2. And I can write 12 as 2 raised to the power of 2, which is 4, then times 3. And that is raised to the power of minus 2, sorry. And then multiplied by, I can write 18 as 2 times 9. And 9 is 3 raised to the power 2. All raised to the power of minus 3 over 2. Okay, so what is that going to give us? So we will try to open the brackets. Now, there is a rule which I have not mentioned, but we are going to see it in other videos. But then let me mention it here because we will need it now. If you have x raised to the power of m and everything is raised to the power of n, if you open this bracket, the two powers will multiply. So you have m times n. So that's what we are going to apply here. Remember that the power on 2 here is 1 and the power on 2 here is 1. So if you open this bracket, 5 over 2 will multiply this power and we'll have 2 raised to the power of 5 over 2 multiplied by 3 raised to the, of course, the power of 3 here is also 1. So we'll have 3 over 2 there. Then we'll now have multiplied by, here you will have 2 raised to the power of 2 multiplying minus 2 is minus 4 times 3 raised to the power of, the power here is 1. 1 times minus 2 is minus 2. So you move ahead. The last one, you have 2 raised to the power of minus 3 over 2. Then multiplied by 3 raised to the power of 2 here. Multiplying these, 2 will cancel 2. So we just have only minus 3. And that looks very beautiful. So what can we do next? We collect like terms. Okay, so let all the powers of 2 multiply. So if all the powers of, all the ones in base 2 multiply, so we are going to have, by the rule that we looked at in the first place, where you add the powers if the bases are the same. So this is going to give us 5 over 2, okay, then times, then we have 3 here, 3 raised to the power of 5 over 2. All right, so from here we try to simplify what we have. So we have 5 over 2 plus minus is minus 4 over 1. And then you now have the other one is also plus minus is minus 3 over 2. And then you take LCM as 2. So here you will have 5 minus 8 minus 3. And that is going to give us minus 6 over 2. And that is equal to minus 3. So here we are going to get 2 raised to the power of minus 3. Okay, so for here we will also add what we have there. So LCM there is 2 also. And this will give us 5 minus 4. Remember, this is over 1. Minus 4 minus 6, which is equal to minus 5 over 2. All right, so here we'll have 3 raised to the power of minus 5 all over 2. Okay, so which is going to give us, of course, this is the same thing as 1 all over 2 raised to power 3, then multiplied by, okay. Alright, so from here we can write this as 1 all over 2 raised to power 3 is 8 multiplied by 1 over, here is going to give us 3 raised to power 5 over 2. Now, because we've not done the law of fractional index, we are going to stop here. So it's either you leave it here as your solution, or you can take it up to this point. And that is the solution to the problem. Kindly subscribe to our channel and do give thumbs up to this video. And of course, you can share our videos to your friends. We'll see you in our next video. Bye.